So in continuation with the previous video, in this video I am going to explain the relation between the equation for velocity, acceleration, displacement, their phase relation, and the general equation for simple harmonic motion. Now for simple harmonic motion, the relation between acceleration, acceleration is proportional to the negative of displacement, because acceleration and displacement from mean position, they are directed in opposite direction, so we have a negative sign. So A equal to minus some constant into x. This is the basic condition for SHM. Now in terms of force, I can write this as force is proportional to minus x, or F is equal to minus kx. Okay, so A proportional to minus k is the proportionality constant. Now what is acceleration? Acceleration is force by mass. So acceleration is equal to F by m is equal to minus k by m into x. So this constant is this quantity, k by m. Okay, so we have acceleration is equal to minus k by m into x. But okay, now what is the value of this k by m? Now assuming this k by m, k is constant, m is constant, and let k by m is equal to omega square. So we have A is equal to minus omega square x. Okay, now as we know that acceleration is also equal to d square x by dt square. So we have d square x by dt square is equal to minus omega square x. So this implies d square x by dt square plus omega square x is equal to 0. So this is a second degree differential equation. Second degree differential equation, for linear SHM. Okay, now the solution to this differential equation must be periodic. Why? Because simple harmonic motion is periodic. So let us assume the general solution of this equation to be x is equal to a sine omega t plus phi. This is general solution where the maximum value of x represents the displacement of the particle undergoing simple harmonic motion. The maximum value of x is a. This is sine. Instead of sine you can write cosine also, because both sine and cosine are periodic terms. Omega t plus phi. This omega t plus phi is called the phase. Omega t plus phi is called the phase. This is the phase, and phi is called the initial phase. Phi is called the initial phase. That is phase at t equal to 0. That is, in this expression, if you substitute t equal to 0, what is left is phi. So that is the initial phase. Okay, so now suppose this is the general solution for this, representing the displacement of the particle undergoing SHM. Okay, so now if I differentiate this with respect to time, dx by dt, I will have a cos omega t plus phi, okay, into omega. So that is, now dx by dt is v, so v is equal to a omega cos omega t plus phi. Okay, now I can write this as v is equal to a omega square root of cos omega t plus phi is 1 minus sine square omega t plus phi. So what is the value of sine omega t plus phi from this equation? X by a. Sine omega t plus phi will be x by a. So this v is equal to a omega square root of 1 minus x square by a square. So that is v is equal to omega square root of a square minus x square. This is the expression for velocity of the particle undergoing simple harmonic motion. So this is one way of expressing this velocity. Now there is another way. See, I can write this as v is equal to a omega sine omega t plus phi plus pi by 2. Now why I am writing this as? So that I can compare the phase of displacement and velocity. Now as you can see, for displacement you have sine omega t plus phi, for velocity you have sine omega t plus phi plus pi by 2. So that means, this means v is ahead of displacement by phase angle of how much? Pi by 2. Phase angle of pi by 2. Okay. So this is between velocity and displacement. Now let us see what is the expression for acceleration. Now if I differentiate this quantity with respect to time again, I will have acceleration. So acceleration a is equal to a omega cos s minus sine omega t plus phi into omega. So this is a is equal to minus omega square a sine omega t plus phi. So this is what is this is x. So I can write this as a is equal to minus omega square x. That is the initial equation we had. Okay. Now another way of expressing this is a is equal to omega square a cos omega t plus phi plus pi by 2. Now why I am writing like this? See, velocity is a omega cos omega t plus phi. Acceleration is cos omega t plus phi plus pi by 2. That means acceleration a is ahead of velocity by phase angle of pi by 2. So see, velocity is ahead of displacement by phase angle of pi by 2, and acceleration is ahead of velocity by phase angle of pi by 2. That means, can I say acceleration is ahead of displacement by phase angle of pi by 2 plus pi by 2, that is pi. So how to represent this in terms of, say, vectors? If this line, if this represents the direction of displacement, then this is velocity. This is pi by 2. Now acceleration is ahead of velocity by phase angle of pi by 2. So this is acceleration. This is again pi by 2. This is acceleration. So see, velocity is ahead of displacement by phase angle of pi by 2. Acceleration is ahead of velocity by phase angle of pi by 2. So what does this mean? See, acceleration is out 180 degree out of phase with displacement. So displacement is in this direction, acceleration is in opposite direction. So this is the reason we had in the first equation I wrote a proportional to minus x. That means acceleration and displacement, they are in opposite direction. Now from this expression for velocity, v is equal to omega a square minus x square, you can see that at mean position the velocity will be maximum, that is equal to omega a. At extreme position, when x equal to 0, velocity will be 0. So velocity is minimum at extreme position and velocity is maximum at mean position. Now if you see the acceleration term, acceleration is a is equal to omega square x. So at mean position x is equal to 0. So at mean position acceleration is 0. At extreme position acceleration will be maximum. So in simple harmonic motion we can see that, see, velocity and acceleration, they are maximum at under two different conditions. When acceleration is maximum, that is acceleration is maximum at which positions? At extreme position. But at extreme position, what is the value of velocity? It is 0. Now at mean position the value of acceleration is 0, the value of velocity is maximum. So see, this motion is unlike the other motion which we studied in motion in one dimension, the normal linear motion, where if acceleration is increases, velocity also increases. It is not so in the case of simple harmonic motion. Acceleration and velocity, they are maximum at two different states, at two different positions. So this is the second part of the topic simple harmonic motion. I hope this was beneficial to you. If you have doubts at any of the steps explained, you can comment in the comment box. Thank you.